The mechanization of agriculture has reduced the cost of food by more than any other change in our means of farming over the past 100 years. Today we want to talk about one of the up-and-coming trends in agriculture, agri-robotics. In particular, we'll be focusing on driverless tractors. With me to discuss what these autonomous vehicles can do, what we want them to do, and how they might shape farming in future is Dr. Kit Franklin. Kit is an agricultural engineering senior lecturer at Harper Adams University and principal investigator of the hands-free Hectare and hands-free farm. He is an inspiring engineer who exemplifies the importance of asking challenging and captivating questions. I urge you to go and take a look at some of the work achieved by Kit and his teams. It is fascinating and raises serious questions about the future of farming. Now for my conversation with Dr. Kit Franklin. So, to start with, I sort of wanted to get an idea of what you think of as mechanization in farming and actually how mechanization has impacted farming over the past 50 years, I suppose, maybe further back.
Yeah. I mean, so essentially, mechanization is any piece of mechanical equipment that has aided the farming process, the agricultural process. So you can take that way back, and I have lecture slides where I do take that way back to sort of cave wall paintings of people scratching a bit of stick through the ground. Essentially that was mechanizing how they could put a seed in the ground. And then you take that right through, obviously draft animals, be it horses or oxen or whatever. All of those, they were using machines and equipment, and that was all the start of a mechanization sort of process, as it were, through to obviously internal combustion and tractors being developed, being the sort of symbol, as it were, I think, of agricultural mechanization the tractor has become. And what that has allowed, if you do take the last, I like to go for the last 100 years just because I can quote it quickly. But if you take the last 100 years, what mechanization has allowed is it's allowed for a reduction in those people working on farm, and the people that remain to still be able to produce enough food. And the numbers on that specifically are, back at the turn of the last century, there were in the UK there were about 2.5 million people working on farms, which at the time represented 5 or 6% of our population. And now we have around 600,000 people working full time on farms, which represents about 1% of our population. So, our population has grown, and in that same time, the number of people working on farms producing the food has declined dramatically. What has enabled that to happen, or what has coped with that happening, is the fact that these machines, tractors specifically, but all the things that bolt to them, and have allowed every individual person to essentially have a greater work rate, a greater output of work. So yeah, that's what mechanization has achieved. It's a bit of a chicken and egg thing, and you can argue, did the creation of these mechanical machines put people out of their jobs, or did the mechanical machines cope with a lack of people? I think it's probably the latter of those. I think there was a general push to urbanization and people wanting to move to warm, cozy offices to work from rather than the field. So I think, and if you look right to today, there is a shortage of skilled, even tractor drivers today. So a modern tractor can do the work of 5 or 6 tractors from the 1950s, and we still struggle to find enough people to sit in those cabs. So it's an ever challenge, is how do we produce this food with not enough people, really.
I would actually almost, I think, quite happily switch the warm cozy office for the slightly cold muddy field. It's always there are enjoyable types of work in farming. I've always thought, but so What was the point of, I suppose, why is it important that the amount of labour that is used, or manual labour, hand labour, individual people used in farming, what's the point of that reduction? Why does it help? Why does it sort of get driven by market forces? Or
I believe that the people have essentially left farming because of the search for a better life or whatever, generally speaking in very general terms. And essentially the machines have allowed the people that are left to do the work that we need to do to produce the food for everyone else. So it's essentially about creating a greater output from each individual. Now, so where I work in robotics, the obvious thing to assume that I am trying to get rid of even more people again. And this is definitely not the case. So the work I do with automation and robotics is all about, again, continuing to cope with the number of people we have whilst producing the food we need going forwards. So, but ultimately, the reason for automation, the things that I'm looking at, is because where we've got to with mechanization as it currently stands has several problems, has several key issues. So, as I've already alluded to, tractors have got bigger, the machines we use have got bigger, and now quite commonly you will see tractors in fields that may weigh 20 or 30 tons. And what that machine is doing is compacting the soil that it's driving over. So if you think, and many of your listeners will may be able to picture that what is a T20 is the little grey Ferguson tractor, very quintessential sort of image for farming from the 1950s, and that tractor would have weighed weighed just around 1 ton, slightly over a ton. And now we're using tractors that weigh 20 times that. They're colossal machines. And the issues we have is that massive amount of weight compacts the soil, basically reduces the ability for roots to push down through the soil. It, it, it it hinders the ability for water to go into the soil. It hinders the ability for air to move through the soil, all of which is needed for crop growth. So the drive to cope, as I've already said, the drive to cope with less people has led to these big machines that are causing us other problems. Another problem is these really big machines aren't very precise. So we're trying to do there's a concept, a management concept called precision farming, which is exactly what it says. It's trying to be really precise in the way in which we farm. So trying to treat subsections of fields as individual parts rather than just fields as a whole. So if you think you wouldn't give if you walked into a pen of animals, let's say, and one was ill, you wouldn't give them all the same medication. But at the moment, we mostly walk into a field and medicate that whole field the same with our sprays and fertilizers. So what precision farming is about is breaking down the field and treating every individual part of a field separately and individually, so we can be much more precise with the way in which we use our inputs and ultimately be more sustainable. But these really big machines we use aren't really good at that because they're so large that they cover loads of ground at the same time, and we're limited by how precise we can be. So yeah, that's where mechanization has got to. It has enabled us to cope with the lack of people. It's enabled farms to stay profitable in a very marginal marketplace where their margins are very tight. So large farms have been able to still generate a profit just about by having these big machines and low levels of staff, but they are in turn causing knock-on problems and are sort of not allowing us to maybe move forward in a more sustainable way.
I mean, the price point was one of the other things that I wanted to just ask and just make it very clear. But is it the case that the larger machines and the greater mechanization has led to a reduction in the price of the crops that we sort of put on our plates or buy from the supermarket type of thing?
It's a really hard one to answer, I think. So we have very large, very expensive machines that are being used by very large farms, which get the benefit of essentially economies of scale, essentially. So they're using less people to cover more land, less machines, but more expensive machines to create more output. And therefore they need to take, I guess, total less of a profit than if that same farm was being farmed by many people, many farms individually. But I think we've been driven that way by market forces that are a need for food to be cheaper, or uh, essentially crops are grown on a global market. So wheat grown in this country is sold at a price equivalent to if it's grown in any other country anywhere around the world, despite how much it might cost in terms of labor and land in those other places. We have a very expensive labor market comparatively for around the world, and we have very expensive, an extremely expensive land market in terms of price per hectare of land. So our farmers have to be very efficient with the way in which they produce food in order to generate profit in such a, when competing essentially internationally.
Yeah. So you have, in terms of the trends. So you said that you're beginning to head into sort of precision agriculture type of territory as a sort of trend that you're seeing at the moment. Is that being reflected in the machines that are being built at the moment, or are tractors still getting bigger?
Generally, tractors are still getting bigger. Again, precision farming has been a concept that was first developed in the early 90s. And again, I can rattle off some numbers to try and explain what's happened since then. In the 90s, the average size tractor on a UK farm was 120 horsepower. Now that kind of doesn't mean much, but then in the 2000s, the average size tractor on a British farm was 150 horsepower. So a sizable increase and again, now we sit here and the average size tractor is more like 165 or 170 horsepower. So in the time since precision farming has been a concept, the machines have continued to get bigger. They've continued to get less precise, essentially. Another example that's maybe easier to picture is that when we go out into a field with a combine harvester that drives up and down the field in stripes, it gathers the crop in, and we can log how much yield is coming in at any point. So we can log the yield in terms of tons per hectare for any given point of a field. Now, the precision of that yield map that we generate is only as precise as the header on the combine. So when yield mapping first came into existence, combine headers were about 6 meters wide. So that meant the resolution of our yield map was about 6 meters. Now combine headers are 14 meters wide. So the resolution of our yield map is now 14 meters rather than 6 meters. So it's actually got half as good. Our precision has actually gone down in that sort of data capture way. So again, what automation and what we can try and do looking to the future, we've got these two clear challenges. We want to get more precise. We want to be able to gather data in a more precise way. We want to be able to go into the field and treat the field in a more precise manner. And we want to be kinder to the soil when we're doing it. All of those things wrapped up in a situation where we have a limited amount of people. Now, I'm not trying to get rid of the people, as I say, but we need to cope with the amount of people we've got, but be more precise, kind to the soil, and ultimately, therefore, the obvious way to do that is to try and shrink the size of our machines and reverse this sort of trend that bigger is better, bigger creates more output. And that's where automation and robotics can come in, because if you basically say, well, if the tractor or let's just say the machine working in my field doesn't need somebody sat on it, then I'm not limited by the number of people I can employ. Therefore, that thing can become smaller, and we can shrink the size of the machines that are in the field. Potentially, we can go to a situation where we might have 5 or 6 machines in the field, just like back in the 1950s, we would have had 5 or 6 tractors in a field. We go back that direction, really. So that's what the ideas around automation sort of open out.
So what you're saying is that what you're working on at the moment is automation within this sphere of sort of farm machinery or in agricultural sphere. Um, but what you expect to see is actually the reduction in the size of these tractors. Is that down to a point that you saw when tractors first came around, or are you talking tiny, tiny little robots?
So I'm not. I don't wish to state too clearly on this because I can't see the future. There are those in my community who want to see things go to a tiny size, things that I liken to vacuum cleaners. So really small robots that go out into the field, many maybe tens of them in a field, going around weeding and sowing and scurrying across the ground. Now the problem with that is that there's a couple of problems with that. A, you're just going to need an awful lot of these things. B, what happens when they meet a bit of a hole or a rut in your soil? You know, soils aren't flat, smooth things. It's not like running around on a car park or even a playing field. You know, fields can be rough and lumpy and bumpy. Um, so there's a practical issue with going really tiny. There's also an issue that a lot of people sort of don't quite believe it, so it's almost a bit unbelievable. Um, so the work that I've done has been to basically look at tractors from yesteryear and say, well, we know we used to farm. There is no question that we can farm with smaller tractors. We used to do it. So why don't we just go back to that point? Whereas if you start going, right, we're going to have things that are the size of a vacuum cleaner, then there is debate if that's even possible or not. Whereas there's no debate that farming with a small tractor is possible because we used to do it. If you go to India, if you go to China, if you go to vast parts of the world, they still farm with small tractors, the tractors that we would have used in the 1950s or 60s here in the UK. So the work I've done has been around about automating tractors and machines of that sort of 1950s size. So just over a ton in weight, between a ton and a ton and a half of mass, around sort of 40 horsepower in power. And we've looked at basically automating those machines. Now, I'm not convinced that that's necessarily the right size, but what the work I've done has been about is actually just having a go, because so many people discussed and debated, could we farm with robots, and no one was really getting on with it. So me and the team I work with just basically had to eventually pick some numbers and get on and have a go and start learning, really.
I love the gung ho attitude is always it's a doer's attitude. Doers are always the people who get things done. Basically, I mean, you've got to start somewhere, and if you always sort of think that you're not quite in the perfect position to get going, then you never end up starting. Can I ask you, what is it exactly that you are automating on these machines? Is it them driving from the barn to the field and opening gates on the way and all of that sort of stuff, or where does the automation start? Where does the automation finish?
We have done what you've just described. We've made tractors drive from our farmyard out to the field, communicate with gates and open and shut gates as it goes. We did that as a sort of one-off technology project. We hope to pick that work back up at some point, but the majority of our work has been based upon field activities and essentially growing crops. So the project that I'm known for is called the Hands-Free Hectare, where we essentially were the world's first people to grow a hectare of cereal crop entirely using automated machines. So nobody stepped foot within our hectare field for the course of a whole growing season. So the tractor went in, it drilled the crop into the ground, so it planted the seed. It then went back into the field 7 or 8 times to apply fertilizers and the chemicals and pesticides and herbicides that the field needed to grow healthily. Um, and then we went in with an autonomous combine harvester and we harvested that crop. That was back now in 2017 that we did that. And yeah, so really we have concentrated on basically navigating tractors around fields without people on them, lifting and lowering the machines that are on the back, so putting the machines in and out of work, um, and that's really where we have concentrated. Say it's not that we don't consider maybe driving around the farm and things like that to be important, and that will become important in time, but we've concentrated on getting the jobs done in the field, and as it were, we've as we've just sort of alluded to, we've sort of done this learning um, because we got going. Lots of people were discussing it, debating it, couldn't work out where they wanted to start, couldn't agree on what was the optimum size, couldn't agree, and we just started, and now we have knowledge. So I have a colleague who always says that I need to remember that in the land of the blind, the one-eyed person is king. um, and we are the one-eyed person, so we know a little. We've had a go. It's not perfect, but we've started to learn.
What did you start with, and how have you iterated from that initial go point?
So we start with basic farm tractors, or compact tractors. The sort of size and scale you might see working in a park or on a golf course. That's the sort of tractor. So it's a 40 horsepower tractor, and if you think of what you might see, say, in your local park, it's probably similar to what we're using. Um, we then basically adapt the human control. So that the first machine we used was very mechanical, so lots of levers and linkages, that you manually pull and push. So we literally took control of those mechanical linkages with electrical actuators, um, and to move them, and then we basically control those actions via a sort of originally with a drone microcontroller. So basically a drone autopilot using GPS. So everything we do is based on GPS. We're very lucky in the sort of field environment that we've got clear views of the sky, and we can get great accuracy with our GPS. And we use real-time kinematic GPS, so RTK. That gives us a accuracy, a precision of around 2 centimeters.
It's centimeters, not meters, isn't it? Because the normal GPS ends up doing meters.
But that isn't just between now and 10 minutes time. I know where I am. I can come back to the same point within the size of a 50p piece year on year. So I can go exactly the same place in the field. I can do exactly the same route again. So we basically take our field, we generate route plans for that field, and then the tractor uses GPS to navigate a predetermined route path, essentially, and then it sends signals to all these systems that we have made autonomous. Now, we do also do this with some slightly more advanced machines as well that are fly by wire, as it were. So where essentially the tractor that we're starting with utilizes electrical signals rather than physical levers and linkages, and there instead what we do is we just plug in and we duplicate the signals we need to take control of the tractor. So yeah, so that's what we do. We now work. It started with drone autopilots, but we now work with a commercial company called FarmScan Ag, and they are developing a proprietary retrofittable control unit. So this will be, we call it the beam. It will go on the cab of any tractor, and with some sort of black box integration, we'll basically be able to control any tractor and make it drive around a field, following predetermined route plans. So that's what we do. All the implements and the things we do in the field are essentially completely standard. They're up in the world of farming. So the seed drills and the sprayers and those things are all completely sort of standard. They're generally as high tech as we can get. So we have a very advanced sprayer that is 15 meters wide, but it applies the whatever the input you're putting on the chemical. It applies it in half meter bands, and we can turn off half meter of our sprayer at a time. So we can be as precise as we can, but that's a commercial machine. Yeah, so the only other thing that really has to go on the machine is some element of safety. These, as I say, we're not using forward-facing sort of control systems like you might see on an autonomous car, where they're using lidars and radars to actually navigate the car, but we use those same sensors purely as a safety. So if something was to be in the way of our tractor, it wouldn't just plow on through, quite literally plow on through. It would see that and stop. But it's really critical that any obstacles within the field that are static and permanent, we will map around. So if we have power pylons going through the field, we will map that and we will basically generate routes that avoid all those things. So we don't leave it up to the tractor to decide which way it wants to turn left or right around this power pylon. We will have predetermined that before the tractor even gets to the field.
In terms of the retrofitting aspect that you were just talking about, because so often farmers there is a large section of farmers who don't buy the top of the range machinery and go for the the secondhand stuff because it ends up being a lot cheaper. It tends to do pretty much the same job that you would get off the first hand machinery, and their budgets might not extend to the sort of incredibly expensive combine harvesters, let's say, or something like that. How important do you think getting the second-hand market is in terms of extending the reach of robotics in agriculture?
Yeah, so I think this sort of retrofit system is always really important, and we've seen that several times before. So again, what your listeners may not know is that most, or now I can nearly say most, probably 2/3 of tractors in this country will drive themselves in straight lines on commercial farms. Um, in the sense that they have what we call auto steer. And what the auto steer allows to happen is there's still a driver in the seat, but when they set out across a field, they click a button and the tractor will hold itself in a perfectly straight line across the field. And that allows them to be much more efficient in terms of they don't want any overlap between pass to pass. Essentially, when you're doing anything in a field, you're like coloring it in. And every time you go over somewhere you've already been, you're wasting time and energy and effort and money essentially. So we already have a system called auto steer, which allows us to very precisely only go across all the field once. Um, that came to market through the retrofit market, so the first products in that space, you had a tractor, you bought a retrofit fit equipment, and that was fitted to your tractor, and that started sort of early 2000, 2003, 2004 was where that really started kicking off. But now that is comes from the factory. So now when you go and buy a tractor, it will have auto steer and the control system required built into the machine. Um, the same, it's just like in the normal world, I guess, or in the consumer world. Sat navs in cars. You used to buy one and stick it to your windscreen. Now your car comes with a sat nav built in. So essentially, what we're doing with this retrofit system is saying, look, it's going to be a while until the big manufacturers, offer tractors that drive themselves, but we're going to start the ball rolling with a set of equipment that you can fit to any tractor of any age within reason. Yeah.
What are the other low-hanging fruits or do you see this as a low-hanging fruit? And if so, are there others that you would like to be grasping for, you think we should be trying to grab?
So the work we do, I would say, is a mixture of low hanging fruit and not. So when our machines are in the field and we are cultivating, so turning a field brown, essentially, it's low hanging fruit. It's very easy. We put a cultivator or set some discs on the back of the tractor, and we just have to drive from one side of the field to the other side of the field, covering all the ground. Very simple, very little to go wrong. It's very easy to automate. It's very easy to walk away from and just leave the tractor to it. When we're doing something like combining the crop at the end of the season, yes, the combine has to navigate from one side of the field to the other, but there's also many things that can happen. The combine can get blocked. It can start pulling the roots of the crop out of the ground and creating big ruts in the field. So there's an awful lot of sort of refinement there before that becomes a really commercially viable thing to sell a farmer. So the work we do is across the whole range of the cropping cycle. Some of it's very easy and will be seen on farm very soon. Some of it will take a long while before it's reliable enough to get there. Now, outside of my industry, the direct work I do, there's always a lot of talk around automation in the world of sort of fresh produce and fruit production. And a lot of the attention is always put into the harvest of that fruit. You always hear people talking about, oh, we need to make a strawberry harvester because we don't have enough labor force to pick the strawberries. Now, I look at that and I just always shake my head because I know that picking strawberries is very, very hard to do it. We've had it, we've done it here at Harper Adams. We've had a project where we've done it and we did it successfully, but it's quite slow, it's quite complicated, and it's quite expensive. Now, on that same fruit farm, around 50% of the labor force will be involved with logistics. So the fruit will be picked, it will then be put into punnets, and those punnets will be being driven up and down polytunnels, taking it to a lorry. Now, as far as I'm concerned, the low-hanging fruit in the fruit example isn't the picking the fruit, it's the shuttling fruit around, just like what Amazon might do in their warehouse or whatever, you know. So there's definitely low-hanging fruit across the industry. If you look at every sector, you can go, that's the bit we should be looking at automating because it's the easiest to do. And it's not always the bit that's getting the attention because to be honest, the funders like to see innovative, exciting looking projects. And if you apply to a funder to say, I want to develop a thing that's going to move strawberries from A to B, they probably go, that doesn't need funding. Whereas if you say, I want to pick strawberries, they probably do fund you. So yeah, that's something that goes on quite a lot. The other one that is definitely happening is around there is a realization clearly within all industries that we need to get greener and more environmentally friendly, and it's no secret that farming uses quite a lot of inputs and chemicals into food production. Now, I'm certainly no one who believes that we should completely cut out chemicals completely and go organic. I believe they've been very fundamental in producing the food we need as a nation and internationally. But we do need to do our bit in cutting back on the use of any sort of input and energy, essentially. So things like hoeing and weeding robots are coming through now, where essentially when you plant a crop, you could put quite a small light robot, going back to the very start of this, a small light vacuum cleaner light robot into your field, and it would just go up and down all day long, just basically pulling out weeds as they emerge when they're really small. So don't let them get big where we need to yank them out with a big machine or put a lot of chemical on them to kill them. Just have a small machine scuttling up and down, kill it up, just weeding the weeds as they come through. And that is quite a low hanging fruit that is being tackled by a number of companies internationally.
Yeah. We actually, I mean, in terms of the strawberry picking one, we might be talking to a company called Dogtooth, who I think do a bit of the harvesting on the strawberry problem. But it's a really interesting point that in all of these things, it's always like where do you go and automate first? What should we really be aiming for? Because if you choose the right things first, it probably means that it makes getting funding to do the difficult problems easier in future, I would suspect.
Yeah, I mean, the old adage of robotics is it's to replace the dull, dirty, and dangerous, and if you always look for dull, dirty, dangerous, you're in a good starting point. And I'd argue running strawberries up and down polytunnels is probably quite dull. So it's a good place to start.
Uh, so when you were doing the hands-free Hector, one of the things you did was generate quite a lot of PR. Why was that important? And I mean, does it fit in? Is it something that was fundamental to the goals of what you were trying to do with the hands-free Hector?
Yeah, absolutely. So on lots of different levels. So on one level, agricultural automation had been talked about in an echo chamber for 20 or 30 years. No one was ever making any progress. So we decided we were going to crack on, do some farming with an autonomous machine, and we were going to tell everyone about it and move that story on. So within our sort of world, it was important to get a decent amount of publicity so everyone knew we'd done it. That was to hopefully encourage some, in a sense, competition, because I certainly don't sit here and think we're the best people in the world at this. I just think we were the people who got on and did it. Um, and by us showing it could be done, I'm sure has inspired other people to get into it and move it forwards. And my interest has always been in advancing agriculture as a whole, and that doesn't mean I have to do it all myself, but if I can inspire other people to move into this space and do that, that's great. So it was about showing that automation was possible. That was both to the sort of engineers who'd been discussing it. It was the farmers who a lot thought it was a long time away. I used to have conversations with farmers about when do you think automation is going to happen, and the common response was 2050, or not, essentially not in my lifetime, or 30 years, or whereas now we did hands-free for Hectare. Everyone saw that in the farming world. It went very sort of viral, as it were, in our industry. So now most farmers, if you say to them, when do you think you could see an autonomous tractor, they now respond with, oh, probably 5-10 years, because they've seen it, that it can be done, whereas before they hadn't. So really important for that aspect. Now, wider than that, and this wasn't really, I guess, the initial aim, but I'm a believer that yeah, say agriculture is the backbone to civilization. It is the few feeding the many allows the many to do all the other things we enjoy, so, media and arts and sport. And if we were all having to produce our own food, there wouldn't be a lot of time for all those things. So the problem is that 99% don't tend to realize how advanced and clever and the challenges that agriculture face. So it wasn't really an initial aim, but I'm very proud of the fact that my project has been presented to, thousands, tens of thousands, millions of people through TV programs and things, who have now seen it and gone, wow, agriculture is way more advanced than I thought it was. I thought it was all wading around in mud up to your knees. So 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 that's, I'm really proud of the fact that I've hopefully shown agriculture and some of its challenges and some of its, advanced features to the wider public.
Providing some food for thought, I suppose. What are the current lines of research that you're now looking to pursue now that you've completed the hands-free Hectare? Where are you going with this work now?
Yeah, so rather sort of inevitably, we're now the hands-free farm. So now we have a bigger amount of area, a bigger farm area. We have 35 hectares of land over 5 fields. Those fields represent a very sort of normal farm for this country. So the fields aren't all square and flat. They're various sizes and shapes. There's footpaths and trees and all the obstacles you would find. So our original project was a square flat field. Now we have a farm that has all the farming challenges that everyone else has. So that ups the ante of our work no end. But and basically means we have to refine everything and get everything better. As I say, I'm an academic, and we are studying it from an academic point of view, critically looking at the economics of it. And we have publications out that show that are modeling the economics of what we're doing and show that there is a potential to improve the profit margin of farming by adopting the technologies we're developing, and critically make smaller land areas profitable. So I mentioned earlier that it's a case of, big farms can make profit, small farms can't. Well, our technologies, because that it is essentially cheaper to get into, and it's cheaper to produce the food, we can make smaller farms profitable again, which is fairly, which could cause a fairly fundamental change to UK agriculture, and globally. So that's what we're doing from an academic point of view. But our project partners are developing products, so retrofit systems. We also work with another company called Precision Decisions. They do the route planning and the control system, the sort of the interface, as it were, the app that you'd have on your phone, that sort of stuff. So those companies that we work with have genuine commercial output that they're trying to achieve. We have this academic study that we're trying to achieve. The big thing that we're doing on Hands-Free Farm is this. One of the ideas is if we make all our machines smaller, we do more of them, and therefore they have to operate in a swarm. They have to operate 2 or 3 at the same time. Now, in the Hands-Free Hectare, we didn't need to do that. It was small enough we could just do it with one machine. Now we have big enough areas that we operate 2 or 3 machines together in the same field. So harvest is just gone. We had a combine harvester cutting the crop and a tractor autonomously driving alongside the combine, unloading the grain, and then avoiding the combine on the turns, driving away and getting out of the way of the combine, and then pulling back alongside on the next run, and that's all being done autonomously. And going forward this year, we will be drilling the crops with 2 tractors, if not maybe 3 tractors at a time in the same field, covering the ground. So that's the sort of the nitty gritty, like the what is the challenge we're doing is sort of this swarm stuff now. But ultimately, it's about, for us as academics to study it, and for our commercial partners to generate products that can be taken to market.
Does this change the nature of what a farmer would have to do? I mean, you're no longer a farmer in that scenario becomes much more of a sort of manager of one of these swarms potentially, and making sure it continues to run rather than actually focusing on an individual machine. Um, does that mean that you then, those user interfaces are sort of, the point of them is to enable a farmer to manage multiple machines, all doing their separate jobs?
Yeah, absolutely. So as a tractor driver, rather than a farmer, I will say, as a tractor driver, you spend a lot of your time driving in pretty straight lines. Now, for 10% of your time, you're absolutely needed because maybe something's gone wrong on the machine. Something's broken, or you've pulled up a big lump of soil, or you're having to navigate around a tree or a tight area. But for an awful lot of the time, the human resource that we struggle to get onto farm isn't really doing a great deal other than driving in straight lines. So what we're trying to do is get that human resource off of the tractor, allow them to remotely monitor 2, 3, 4 smaller vehicles that are doing the same work, and then free up the time that they're not having to. I'm not saying they'll never have to go and rescue their robot tractor. Of course they will, and they'll have to work on them and do maintenance. But we're being able to free up that tractor driver to do the higher value jobs that we have on farm. So the agronomy. So what is the crop looking like? What's the soils looking like? Dig some holes with a spade. What's the ecology like? Ultimately, be a business person. Farming is so multifaceted in what you have to do. You have to decide when to buy and when to sell. In the last 2 weeks, depending on when you sold your wheat, you would have made £15 different per ton. You could have sold it for as little as £180, and you could have sold it for as high as £195. So that's a job in itself, deciding when you sell your crop. So if we can get people off the tractor, let the tractor do its thing, we can free them up to do all these other tasks that are actually probably earning them more money, and earning the business more money.
Okay. And for people interested in getting into this sort of line of research, can you give them any advice? Is there, I mean, how should they start going about that? What are the things that you need to do to start working on some of these important and interesting robotics problems?
Yeah, so I think, well, there's some really general ones. So um, very generally, autonomous vehicle safety is a thing that I know a number of companies that are crying out for a more sort of rounded, sort of one-stop shop of a sort of safety solution. At the moment, you've got lots of companies developing autonomous vehicles and having to develop their own proprietary safety system. Some sort of standardization of the best system would be a great thing to do. So that's somewhere to look in a very general automation sense. Safety systems need to be better, cheaper, more reliable. In the more sort of agricultural area, i.e., are we farming in the best way? Trying to decide what amount of chemical or what amount of seed I'm putting into the ground, or how I navigate my field to be most efficient. Those sorts of questions. Um, there's an infinite amount to answer, and my advice to everyone always is get yourself onto a farm, and you'll soon see some of these problems. And I really believe this. So I, you know, I'm not a farmer. I am an agricultural engineer who tries to solve farmers' problems. But I spent a good number of years working on farms through holidays and whatever else, to have a really clear understanding of the sort of failings on farms. And I really believe that if you want to get into this world, just go and work on a farm for a handful of days, and you'll start to see the problems that need solving. And then in the more, again, I guess, automation thing, well, there's now tons of companies and research teams out there in this space. So go and talk to people and say, what are the problems you're working on? What are the problems you're seeing? And I'm sure there's lots to solve. There's plenty to go around.
Okay, that's great. Very, very good advice, I think. So, final question is: do you expect to see these? So, you said that farmers are beginning to say they expect to see them in sort of 5-10 years. Do you think that the problems that are left to solve are going to we're going to be able to do these things in the next 5 or 10 years, or do you think it's actually going to be a longer term problem?
Back in 2016, when hands-free launched, I was asked a lot, when will it be commercial? And I said, at that time I said around a decade. And in the last 5 years, the amount of things that have happened have only reinforced that in my mind. That by midway through this coming decade, so 2025, 2026, there will be autonomous vehicles and systems that are commercially viable for farms. So the way I normally say this is it will be unsurprising to see an autonomous vehicle on a farm in 5 years' time. That doesn't mean that every farmer is running a fleet of autonomous vehicles. It doesn't mean that every vehicle is autonomous. But if I'm driving across the countryside and I see a weeding robot out in a field doing some weeding, I don't think that will surprise me in 5 years' time. There's already a number of commercial companies selling these systems now, and it's going to become more and more commonplace.
Well, an exciting future. Thank you for listening to this episode of the Biotech Podcast. If you'd like to find out more about the show or the researchers we've been talking to, you can either check out the description on your podcast player or head over to our website at thebiotechpodcast.com. Thank you for listening, and please reach out with thoughts and comments about the